pi electrons in a cyclic arrangement of 2p orbitals.
So when you look at that structure, we've got to go through all of your rules. So your first rule, I already forgot. What was the first rule?
2p orbitals per atom.
Short attention span. 2p orbitals per atom. So the oxygen atom, what's its hybridization?
sp2.
sp3, because of the lone pairs.
The lone pairs. But I always forget about them.
But those lone pairs, because it's an sp3 atom with lone pairs, we can count one of those lone pairs. So that's allowed to rotate in. So those will count as a p-like orbital. We can then go and count out the rest of the carbon atoms all the way around the ring, right? So if we look at the next 4 atoms on either side, what are the hybridizations?
sp2.
sp2, because we've got 3 electron groups, because they all have that hydrogen coming off of them. What about that bottom carbon?
It doesn't have,
sp3. Does it have a lone pair that it can donate in? No. So does it have a p-like orbital? No. So according to rule 1, that structure is not aromatic. Does that make sense?
Yep. Yeah.
Okay. And for the benefit of those of you at home,
So you're totally going to end up recording me cussing at some point.
what's that?
So you're totally going to end up recording me cussing at some point.
Makes me feel like not want to talk.
I'm gonna pause it in between. Because yeah, I think the random conversations are not going to be a good idea.
Oh my god.
So Lewis for boron, 3 valence electrons, which means is sp2, has an empty p orbital, so they all have p-type orbitals. 2, 4, 6. We validate our 6 pi electrons, and we're circular. So the structure is aromatic. So yeah, for question 9-11, so in chapter 9, question 11, what you're trying to do is compare the acidity of those 2 structures. So if it's an acid, draw out that reaction. See what happens if it acts as an acid. So if we look at that structure, which hydrogen, so do you agree that the rest of those hydrogens are going to be the same? Which of those hydrogens is going to be the most acidic?
The ones where the double bonds are at.
Yeah, the ones that are
Forced to be more.
Okay, so let's take a look at each of those possibilities. So we'll go through and call this one the red option. And we get the lone pair and a negative charge. What happens? My favorite color is blue, by the way, just as a hint. If we removed the other hydrogen. So now it's a question of looking at both those structures, and we can go actually back to the last question that was asked. Are these structures aromatic? Our red structure, that carbon right there, has what hybridization? sp3. Well, if it's sp3, according to rule 1 of our Huckel rules, it doesn't have a 2p orbital. Negated, we can't have aromaticity in that structure. Okay, regardless of our negative charge. If we move to the other one, we look at that same carbon, we could call that carbon sp3 again, except do we have a lone pair that is resonatable? Yeah, I can do resonance, pushing it into the ring. Okay, and then pushing the charge around the ring, which ultimately means resonance stabilizes this anion. This one has no resonance stabilization. If we're looking at it trying to become an acid, we're trying to pull off an equivalent H+ in both cases, so that's not going to change. It's coming down to the stability of your conjugate base. Which one has the more stable conjugate base? The one with more resonance. So with our blue structure, we end up getting more resonance, which means that conjugate base is more stable, which means that hydrogen is more acidic. Okay, so does that make sense for why that hydrogen is the most acidic one in that structure? Okay, we're all good? Okay, so then what we've got to go through and do, and we'll erase all of that very, very slowly. Very, very slowly. Come on now. Meow.
Oh, yeah.
Thinking about doing that for the chair of the department who's going to sit in on a lecture. Thinking about attempting to try and do that during the lecture.
That would be hilarious.
For the chair. That would be awesome. So
Are you talking about
the
the chair?
Mike Sims chair.
What's his name? The old guy from like that really racist movie?
Okay, now we should probably pause.